Alright, let's look at the homework 4.7, problem number 8. Alright, so we want to find the equation of the line through the point 2, 5 that cuts off the least area of from the first quadrant. Alright, so let's do that. So I already drew the picture. Alright, so here's the x-axis. Oops. Here is the x-axis and y-axis and the origin. Right, so this is a line that cuts through 2, 5. So we know the point that it passes through, but we don't know the slope. So let's call its slope m. So this guy has a slope m. Right. So the equation is going to be just a y minus phi y1 is equal to m times quantity x minus x1 would be 2, right? So this would be the equation, right? So in order to find this triangular area, we need to know the base and height. Base is simply the x-intercept, so plug in y equals 0, and we'll get that's a negative 5 is equal to m x minus 2. Then we can just divide through by m to get the negative 5 over m is equal to x minus 2, which means that adding 2 to both sides, x is equal to negative 5 over m plus 2, right? Right, so which means that this guy right here, so this guy right here is a negative 5 over m plus 2. Alright, how about the height? Height is simply the y-intercept, so we set x equals 0. And then you have a y minus 5 is equal to 0, negative 2m. Right, then we can just add the 5 to both sides, so we have y is equal to negative 2m plus 5, right? So which means that the height here is negative 2m plus 5. Alright, so the area function, so area in terms of the slope m is going to be 1/2 base is negative 5 over m plus 2 times height, which is negative 2m plus 5, right? So if you multiply it out, you're going to get 1/2. I'll just keep it out, and let's see, this times that gives you 10, right? M cancel out, right? So I'm just distributing this guy to that guy and this guy to that guy, so we'll get the negative 25 over m, right? Then we distribute the 2 to negative 2m, then you get the negative 4m, and then distribute 2 to 5, we get another 10 plus 10. Alright, so if you simplify that, you're going to get let's see, it's a 1/2, just to keep it out. Alright, 10 plus 10 is 20, and a minus 25m minus 4m, right? So if you take the derivative, a prime of m is equal to, so 1/2 is just a constant multiple, and derivative of 20 is 0. Derivative of negative 25 over m is 25 over m squared. And derivative of negative 4m will be negative 4. Right? So we set this guy equal to 0 to find a critical number. So this is going to be, let's see, 25 over, so I'm going to solve for m squared first. That would be, so set this guy equal to 0. We're going to get 25 over 4 is equal to m squared. Right? Which means that the m has to be plus or minus square root of 25 over 4 is 5 over 2. Right? So in this case, in order to create a triangular region, the slope has to be negative, because if it's positive, then it wouldn't enclose. It's actually its region. It will be unbounded. So we know that we're talking about the negative slope. So this is going to be the one, right? So the equation that we are looking for is going to be so m equals -1. So we just have, so therefore equation is y minus 5 is equal to -5/2 and x minus 2, right? Let's type it in. Make sure that this is going to be the minimum. If you look at the let's see, if you look at the derivative equation, maybe I should do that here, right? So I'm going to do a small number line, right? Then we're talking about the negative value. So here this is going to be 0, and here we have -5/2, right? So if you try anything less than -5/2, like x equals -3, and you see that the -3 here, it's going to be -3. So 9/25/9 minus 4, so it's going to be negative, right? Negative here. And after that, like -1/2 or something like that, then this will be positive. So you have a positive here, right? So you have a decreasing picture turning into increasing. So we know that here we will have a minimum, right? So this will be right. All right, so let's type in the equation. So we know that our equation is y minus 5 is equal to -5/2 quantity x minus 2. All right, let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.